Assalamualaikum and salam sejahtera. I am Hidayati Asrah from Civil Engineering Program, Faculty of Engineering UMS, and today I'm going to present my paper entitled Optimization of the Grid Interlocking Compressed Earth Brick Mixed Design Using Response Surface Method. As an introduction, Malaysia produces a considerable amount of waste due to growth of population and the booming economic industry, in which only 25% of the waste materials are sent to the sanitary landfills. Malaysia is also one of the main exporters of palm oil, producing tons of palm oil to be exported to other Asian and European countries. As a result, million tons of palm oil waste have been created, and majority of the waste, such as fibers and shells, are being disposed in the landfill area. One of the ways to use this waste material effectively is by incorporating them into the construction sector, especially into building components such as interlocking brick. The interlocking brick also provide lower cost of production and installation, but currently there is very limited study on optimizing the mixed design of green interlocking compressed earth brick or ICEB using spent bleaching earth, ash or SBEA. So SBEA is a waste from the palm oil refinery plant, and without economic benefit, SBEA is usually dumped at the landfill, and this causes pollution to the environment. Therefore, due to overflowing SBEA in palm oil industry, and it is difficult to manage its disposal into the landfill, other alternative is to use SBEA as the raw main material in the building components. So in this case, we use the SBEA in the production of interlocking compressed earth brick or ICEB. The ICEB are generally manufactured with machinery and ready-made molds at factory in a large scale. However, finalizing the optimum green ICEB mix proportion is a time-consuming process. It takes time to discover the best mix design based on the lab testing. On the other hand, the behavior of this green ICEB in terms of the compressive strength and water absorption is difficult to visualize using observation and analysis on paper. Response surface method or RSM, it can be used to optimize the interlocking brick mix design. However, only few researchers use RSM to optimize the interlocking brick, and they also use scrap tires and waste plastic in the interlocking brick production. RSM can be used to create a prediction model and visualize a three-dimensional plot for the response behavior of the material. It is a compilation of mathematical and statistical methods, which is helpful for fitting the models and analyzing the problem, where a lot of independent parameters control the dependent parameter. Okay, therefore, this research aims to optimize the mixed design of the green ICEB containing SBEA using the RSM. And also, from the obtained formula, we are going to investigate the relationship of semi-replacement using SBEA towards engineering properties of the green ICEB. Optimization of the mixed design will contribute to manufacturing of higher quality green ICEB containing SBEA. Where the obtained results, they may improve reliability of interlocking brick in the construction industry. And the established formula obtained from the RSM also can be used as a reference for the producers to produce ICEB which meet the required strength and water absorption requirement. So this can be useful in terms of time saving and faster work in determining the best green ICEB mix design. And in addition, it will provide a starter for future researchers to proceed with studies regarding the green ICEB optimized by the RSM. The methodology of the research is basically divided into two phases. Phase 1 involves computer modeling using the RSM, and in this stage, the parameters used for modeling were identified and then inserted into the Design Expert 11. The independent variables are the cement and SBEA. Meanwhile, the response value to be found are the compressive strength and water absorption. Formula generated from the RSM was then evaluated to find the optimal mix design for the green ICEB with SBEA. And to evaluate the reliability of the model obtained from the RSM, validation was done using the Minitab 19. And in phase 2, we investigate the relationship between the engineering parameters and properties of the green ICEB using the 2D and 3D contour plot. So this is the Design Expert version 11, which is used in this study. And to develop the RSM model, we use previous data obtained from Haril 2020. So table 1, this is a secondary data from the testing of the ICEB specimens at UMS ICEB production factory. It consists of 9 data for independent variables such as cement and SBEA at 0 to 50% partial cement replacement, as well as responses of compressive strength and water absorption. In the RSM model development, the factors and coded factor level used are as shown in table 2, and the coded factor level was used to help the interpretation of the coefficient fit to any experimental model. So in this coded level, the high maximum value they becomes +1 and minimum value becomes -1. And in this study, the minimum coded level for cement is 9.25, while the SBEA is 0, and the maximum coded level 1 for cement is 18.5, and minimum for SBEA is 9.25. Optimization of the green ICEB mix design was done by using the numerical optimization, where the independent variables are the cement and SBEA, and response variable are the compressive strength and water absorption. And then we determine the goal for each parameter, where the cement was adjusted to be in the range between 0 to 18.5. Meanwhile, the SBA was from 1 to 18.5. Then weight of each variable was determined, and in this study, weight of the variable was set to 1. Okay, and then the 2D and 3D contour were plotted. From the plotted contour, the relationship of cement and SBA towards the compressive strength and water absorption can be studied. Okay, result and discussion. Okay, after analyzing the data using the Design Expert, the RSM model was generated in the form of mathematical equation. The mathematical equation for compressive strength is shown in equation number 1. So this mathematical equation was used to predict the response based on the interaction between the independent variables. The difference between the predicted and actual response are represented as residual, which is obtained by subtracting the actual from the predicted response. The closer the residual value to 0, meaning that the predicted response is more accurate. And from the results in table 3, the minimum amount of SBEA used to replace the cement, which give high compressive strength value, is for SBEA replacement at 10%, where it gives compressive strength of 7.9 MPa. However, replacement of SBEA up to 40% is still acceptable, as the compressive strength is still within the limit of 5 MPa as stated in the British standard requirement. Figure 1 presents the normal plot of the residual for the compressive strength, which obtained from the RSM modeling. It can be observed that all residual data are approximately fall on the straight line. Meanwhile, figure 2 shows the predicted response against the actual response graph for compressive strength. And it can be seen that most of the predicted response are placed along the straight line of the actual response. And figure 3 shows the relationship of compressive strength between the residual and predicted response. From figure 3, it can be seen that all the data fall between the limits, which are 4.6553 and -4.6553, and also closer to the 0 line. Okay. So from all this graph, it can be concluded that the modeling for compressive strength is acceptable due to the high accuracy data obtained. Okay, for equation 2, okay, it shows the mathematical equation obtained from the RSM modeling for the water absorption prediction. And using the equation, the lowest predicted water absorption obtained is for control specimen, which is 13.87%. But for ICEB with SBEA, the lowest water absorption obtained is for mix with 10% SBEA replacement, which produce 15.1% of water absorption. And the normal plotted value of residuals for water absorption shows that the majority of the residual data falling on the straight line, and most of the predicted response, they are also aligned with the actual response straight line, indicating its accurateness in predicting the actual residual value. And the relationship between residual and predicted response also show that all data fall within the limits. So this indicates that the model is acceptable, okay, because of this high data accuracy. And validation using the Minitab 19 shown in table 5 and 6 for compressive strength and water absorption respectively. So both compressive strength and water absorption show p-value of less than 0.05 with R-square value of 0.7251 and 0.7518, indicating fair agreement between these two models. So overall, the RSM model for compressive strength and water absorption developed by the design expert is comparable with the Minitab 19. Okay, then we go to the optimization of the ICEB proportion. The criteria for strength optimization was each set to 335 for cement, SBEA, and compressive strength. And the software indicated that the ICEB has maximum compressive strength of 7.562 MPa at 94.6, which is 17.47 kilogram of cement, and combined with 5.4% of SBEA, which is 1 kilo. So this compressive strength value is greater than the ICEB with 10% of SBEA, which is 7.17 MPa. And for water absorption, the optimum value was obtained when the amount of SBEA used to replace the cement at 10% with value of 15.1%. And the relationship between the independent variables cement and SBEA with the response compressive strength, they are shown in figure 7 and figure 8. And from figure 7, the change in color from blue to red indicate increase in compressive strength value. Therefore, it can be deduced that high proportion of SBEA and low proportion of cement result in low ICEB compressive strength value. Meanwhile, in figure 8, it can be inferred that the proportion of cement, they are more dominant factor in affecting the compressive strength of the ICEB compared to the proportion of the SBEA. And similarly, for the water absorption, it can be seen that high SBEA content in the ICEB has resulted in high water absorption value as shown in figure 9. And the 3D plot shows that compared to the cement proportion, the SBEA proportion, they are more important in influencing the ICEB water absorption. Okay, and as a conclusion, by using the RSM modeling through the design expert software, the optimized mixed proportion of green ICEB is obtained at cement content of 94.6% and SBEA at 5.4%, which produce ICEB with compressive strength of 7.562 MPa. The optimized green ICEB for water absorption is obtained at 90% of cement and 10% of SBEA, which produce 15% of water absorption, and small percentage of differences between the actual and predicted data shows that the design expert version 11 is able to develop accurate RSM model. And number 4, the cement proportion had significantly greater influence on compressive strength than the SBEA proportion. And the last one is the SBEA proportion. They are more dominant compared to cement proportion in affecting the percentage of water absorption. Okay, so that's all for my presentation today, and thank you.